Good morning, students. Today we are going to start with the recapitulation of another unit from organic chemistry, that is amines. So in the case of the amines, what we have, that you say that alkyl or aryl derivatives of they are regarded as the amines. And these are basically we obtain by replacing one or more hydrogen atoms by the alkyl or the aryl groups. Further, amines can be classified as the primary, secondary and tertiary depending on whether one, two or three atoms of hydrogen are being replaced by the alkyl or aryl groups. Then, related to its structure, it have the pyramidal structure. Means, if we say then each of we say that over here the hybridization will be the sp3 hybridized. Now the main thing coming to the preparation. Preparation of the amines in the case of preparation of amines. The very first preparation method is the reduction of nitro compounds. Now, reduction of nitro compounds mean we are having the RNO2 plus H2 in the presence of nickel or palladium. So what we are going to get? We are going to get the first degree amine. Say suppose you are having a CH3 CH2 NO2 and you reduce it in the presence of the any reducing agent you can take a Fe in the presence of concentrated HCl, you can take a nickel, palladium, Sn, anything. So what is going to happen? Your NO2 group we say oxygen is going to replace. So once I click OK here NH2 will come plus water molecule will get liberated. The second method is the ammonolysis. Now let's discuss about this implicit iteration concept in J3 and let's actually understand that with an example. Let's say we want to change the font color of all these list items to red. Lysis of just pick. Then copy I am removing alkyl halides. Is because I am. So in this we take a excess amount of ammonia. So what is this going to do? This DCSS function. It provides us the first degree amine as the major product as well as NH4X. Now see suppose if your alkyl halide is in excess, then amine formed further reacts with the alkyl halide to further gives the second degree, third degree and the finally quaternary ammonium salt. Means in this more alkyl halide you get, secondary amine you are going to get, then again more amount you are putting, or in the starting taking in the excess, tertiary amine you are going to get, then again making it react with alkyl halide, then finally you are going to get the quaternary ammonium salt. Next preparation method is the reduction of nitriles. In the case of reduction of nitriles, we take nickel, palladium, anyone you can take. It is going to give you the primary amine. Then the fourth method is reduction of amides. So it is what? You have taken any amide, any reducing agent, strong reducing agent you can take over here, the presence of ether. It is going to give you a primary amine plus water molecule is going to liberate. Then next preparation method is what? It is a named reaction. Named reactions are always very important. That is your Hoffman bromamide degradation reaction. In this case, we take a amide in the presence of bromine, NaOH, we get the RNH2 plus Na2CO3 plus 2NABr plus 2H2O. Sixth method is Gabriel phthalimide synthesis. This is also an important named reaction. KOH potassium will come and attach, then making it react with the alkyl halide. So what it is going to give? Your potassium is going to replace and then in the presence of NaOH, NaON plus your primary amine is going to come. Now in this case we say that your aromatic amines cannot be prepared by this method. Always remember, we cannot prepare a aromatic amines. Now the reason being over here is what? Because aryl halides do not undergo a nucleophilic substitution with the anion formed by the phthalimide. Again I am repeating the reason that by the Gabriel phthalimide synthesis we cannot prepare the aromatic amines because aryl halides do not undergo nucleophilic substitution with the anion formed by the phthalimide. Now coming towards the aromatic, that is your preparation of aniline. When we want to prepare aniline, the first method is that we can prepare it from the nitrobenzene. Nitro group you have taken, reduction, NH2, 2H2O. Second method is by Hoffman bromamide degradation reaction. In this method, we take a benzamide, Br2, KOH, and we get a aniline. Besides this, as a byproduct, we get the K2CO3, KBr, and a water molecule is being liberated. Now, according to the physical properties, the give reason question which we can expect over here is the here from the boiling point. In the case of boiling point, it increases with the increase in molecular weight. But when you are going to take the primary and secondary amine, they have the higher boiling points than the tertiary amines of the same molecular weight. This we say it is going to due to the possibility of intermolecular hydrogen bonding between molecules of primary as well as secondary amines. Another thing, pure amines, we say that they are almost colorless, but they start developing color on keeping in air for the long time, especially the aromatic ones. This is the reason is what the coloration is due to the oxidation of amines by the air. Now, coming to the chemical properties of the amines. Chemical properties. The first chemical property is alkylation. In the case of alkylation, what we do, amine is being taken, making it react with any alkyl halide. So what is going to happen? In this case, HBr is going to liberate. One hydrogen is being replaced. Then again reacting it, again HBr is going to liberate. And then again reacting it, so Br is going to come. Means ultimately you are going to get the tetra, like over here we have taken a ethyl, so tetraethyl ammonium bromide is being prepared. Another method is a acylation. In the case of the acylation, amine is being taken, base we have taken, so it is going to give the substituted amide, that is your RNHC from OR dash plus HCl is going to liberate. Now further for the chemical properties, another chemical property is this reaction with chloroform. This reaction with chloroform is a named reaction called as a carbyl-amine reaction. Now in the case of carbyl-amine reaction, we take a amine plus chloroform we take plus alcoholic KOH. Always remember when we have any specification aqueous or alcohol, it is very necessary to mention in the reaction. So it is going to give you a alkyl carbylamine, KCl will get liberate and water molecule is going to liberate, balancing the equation. Another chemical property is reaction with the nitrous acid. Now reaction with the nitrous acid, this reaction is basically useful. The reason being is what it is useful, as it is a it helps us in distinguishing between the amines. If we are having a primary amines, they react with the nitrous acid, RNH2, it is my primary amine reacting with the nitrous acid. So what it is going to do, it is going to provide me a alcohol, Na2 in the presence of HCl. But if you are going to have the secondary amines, it is going to react with the nitrous acid to form a yellow-green oily layer, which we say that it is of the nitrosoamine. Like we are having a secondary amine, nitrous acid, so it is going to give a nitrosoamine. Now this yellow-green oily layer of nitrosoamine, when you are going to warm it with the crystal of phenol and add a few drops of H2SO4, it forms a green solution, which further treated with the aqueous NaOH and turns into the deep blue and then red on dilution. This particular reaction for the secondary amine is going to called as a Lieberman's nitroso reaction. Next one. Tertiary amines readily dissolve in nitrous acid, forming a crystalline trialkyl ammonium nitrate. So therefore, basically, this reaction with the nitrous acid is used for distinguishing whether the given substance is the primary, secondary, or the tertiary amine. Then, besides this, in the case of chemical property of the amines, we have the electrophilic substitution reaction. In the case of electrophilic substitution reaction, due to resonance, electron density increases at the ortho and para position as compared to meta position. Therefore, it is going to direct the incoming group to the ortho and para position. So what is going to happen? In this case, we can have the bromination. Now, if you are going to take a bromine water over here, means a bromine in the excess. So what is going to happen over here? It is going to provide you the 2,4,6 tribromoaniline. But if you are taking a aniline and first of all you are making it react with the in the presence of a pyridine, then Br2, then it is going to give you a para bromoaniline as a major product as well as ortho bromoaniline. Then nitration can be done. In the case of nitration, again you are going to have the ortho and para nitroaniline. Now, if you have taken a acidic medium, then we say a meta isomer is also obtained due to the formation of anilinium ion, which is a meta directing. Besides this, we can have a sulfonation, Friedel-Crafts reaction in this case. With this, we finish our amines preparation and the chemical properties. Coming to the test of the amines. Now, when we go for the test of the amines, then in this case, the very first test is a Hinsberg test. Hinsberg's test, in this we say the amine is treated with Hinsberg reagent. Now, what is the Hinsberg reagent? It is the benzene sulfonyl chloride. So what happens in this case, that we take a amine and it is first made to react with the benzene sulfonyl chloride, and then we shake it with the aqueous KOH solution. On the basis of this, we can identify the three different amines. First degree amine is going to give you a clear solution, which on acidification gives an insoluble N-alkyl benzene sulfonamide. If you are having a secondary amine, then it is going to give you an insoluble N-dialkyl benzene sulfonamide, which remains unaffected on addition of acid. And then we are having a third degree amine, which does not react at all. In each cases, we require to provide the reactions also. Next test is isocyanide test. This isocyanide test we also called as a carbylamine test. This primary amines, aliphatic as well as aromatic, they react with the chloroform in the presence of alcoholic KOH to form a foul smelling carbylamine. Now, secondary and tertiary amines, whether they are the aliphatic or aromatic, they are not going to give this particular test. Then the third test is your azodite test. Just keep in mind in this that it involves a reaction of any aromatic primary amine with HNO2 at a temperature of 273 to 278 Kelvin, followed by treatment with an alkaline solution of 2-nephthol, where we say a brilliant yellow, orange or red colored dye is obtained. With this, we finish the recapitulation of our amines.